Hello and welcome to recording 1A, the first in our series on quadratic functions in vertex form for Unit 3, Chapter 3 of Quadratic Functions for Mathematics 2200. In this recording, we're going to focus our attention on introducing parabolas and functions of the form y equals ax squared and the effects of that a value on the graph of y equals ax squared. You've seen these shapes, I'm sure, in the world. They're often known as arches. At least these two are anyway. And those are examples of parabolas. You've seen many satellite dishes. Many satellite dishes, not all of them, but many have a parabolic cross section. Some features of a parabola. First of all, if we draw the graph of a parabola like this, the vertex would be the lowest point on the graph. So the vertex of this one is right here, and we'll note that it is located at the point 0, 0. In this other graph, which opens downward, the vertex is the highest point, like so. There's something called an axis of symmetry. The best way to explain it is to show it. I'll take this line and I'll move it to a location that passes directly through the vertex. So it's a vertical line that passes through the vertex, and it shares the parabola into two equal halves. So it shows the symmetry of the parabola, which you would have studied. Symmetry is something you would have studied back in grade 9. If the graph opens downward, it also has an axis of symmetry that goes through the vertex. So it doesn't matter if it opens up or down, the axis of symmetry goes through the vertex. The axis of symmetry has equation. I'll just abbreviate those words. X equals 0. It's the y-axis for these two graphs, but it has equation x equals 0 because it is a vertical line after all. Let's take a look at the most basic equation that will produce a parabola, y equals x squared. I've got a table of values here. I've got my table in 3 columns. I like to do that so I can have a calculation column right here. So for example, if I put in -3 for the x, -3 squared works out to be +9. Likewise, -2 squared works out to be +4, etc. I'll complete the rest of the table. So if we take a good look at what happens here, when I put in -1 squared, for example, I get a 1 for my y value. If I put in 1 for my x value, I still get 1 for the y value. So putting in the negative value for x gives me the same result as putting in a positive value for x because of the squaring. The only exception to that rule is 0. 0, negative of 0, same as the positive of 0. So it doesn't have a mirror point like the other ones do. So -1 is kind of like a mirror for +1. 0 is its own mirror. Let's plot the points. Now we can see the points are plotted and they form that parabolic shape. All we need to do now is connect them. So I've connected the points on one side of the parabola. Now I can easily reflect that side to get the other side. So I've shown the other side in a little different color so that we can see the reflection of one to the other. The axis of symmetry is still at x equals 0, so the same as it was in the graph in the earlier graphs that we looked at, and the vertex is at 0, 0. This is the most basic of all parabolic graphs. Make sure you are familiar with it and able to sketch it quickly. Now we'll compare the graph we just did to the graph of y equals 2x squared and see the effect of that value of 2 in front. Completing the table, that a value, the value of 2 in this case, has the effect of doubling all the y values from the base graph. Now let's sketch this new graph. So this graph stretches up twice as fast as the original graph because all the y values were doubled compared to the base graph. And it keeps the same axis of symmetry though, and the same vertex. And here is the axis of symmetry. On with the next example. Right, this graph is y equals a half of x squared. So I've already completed the table. And this 1/2 has the effect of taking half of all the y values that we have for y equals x squared. Let's draw that graph. So when we sketch this graph, it opens more widely than the other graph, than the graph of y equals x squared. That's because that 1/2 forces the graph to grow more slowly. Keeps the same axis of symmetry and vertex. One more graph to go. So we've got the graph of y equals negative 2x squared. The negative 2, well, the 2, first of all, doubles all the y values from the y equals x squared graph, but then it changes their sign because we're multiplying by negative. So all the y values change to their opposites, with the exception of 0 because it's its own opposite. So the graph, when we plot it, opens down, and it is narrower because it is going twice as fast as the base graph. The axis of symmetry, though, and the vertex are the same as before. In quick summary, if the a value is positive, the graph opens up. If it's negative, it opens down. If it's a fraction between -1 and 1, then it will open more widely. If it's bigger than 1 or less than -1, it opens more narrowly.